good morning, depending where you are. Welcome to the Hyperbaric webinar, High Pressure Processing HPP, the best ally in food safety. In this webinar today, we will be three presenters. First, I would like to introduce myself. I'm Carole Tonello. I'm the application director in Hyperbaric for 17 years now, and I'm very pleased to have here to be with you here today for this first webinar in English. We started this monthly webinars because we want to explain more about the technology, and we want to show some success business case with HPP. So my first my presentation, the first presentation that I will give in 10 minutes will be an introduction of HPP, and then the second presenter will be David Rodríguez Lázaro. David is a professor at Burgos University and is the head of the microbiology section. He's an expert in microbiology and in HPP. And the third presenter is Jaume Planella. Jaume is the R&D Director of Noel Alimentaria. Noel Alimentaria is a large meat company in Spain, and the company use the technology, the HPP technology, for now more than 10 years, and Jaume has developed the range of HPP products Noel has now in the market, and he will give some good example and talk about his experience. So I will start with my presentation, and first I would like to introduce briefly the company, Hyperbaric, who we are. So we are the global leader in HPP machinery, HPP food system, with about 60% of market share. We have more than 300 machines now installed all over the world, and in more than 45 countries, with 20 years of experience. Our annual revenue is over 50 million euro, and we are a team of 120 people. Our company really is based on innovation, and we have done more than 20 R&D projects all over our history. Our headquarters, you can see in the picture, has over than 30,000 square meters. We have also people in other continents, especially in USA. In Miami, Florida, we have sales and after sales services. We have people also in Mexico, in Asia, in Singapore, and in Australia. Our range of machine, from the smallest one, Hyperbaric 55. This machine produces roughly 200 to 300 kilo per hour. The cost, just to give you, I know this is always a question we have. The cost of this machine, the first one, for example, the smallest one, is roughly 600,000 euro. And we have a range of different machines: 135, 300, 420, 525, and the last one, the new one, is the Hyperbaric 525 block. This machine allows processing juice without packaging before bottling. And the production of the biggest one, the bulk machine, is between 4,000 to 5,000 liters per hour. So you can see a little bit the range of the machine. the evolution of the industrial HPP system is the one that you can see on the picture. So this is our machine and also the machine of our competitors. From what we know, there are over than 500 machines in production today all over the world. Well, in the first years before 2001, well, technology has the first machine implemented were in Japan at the beginning of 1990. But the first machine are now quite old or were prototypes and they were dismantled. But you can see that really the growth of the technology in the industry has been during the 10 last year after I would say 2010. The growth is quite it's quite impressive. So the technology SPP is considered as a new technology, but we cannot say really that it's an emerging technology. What is HPP? So starting really with the introduction. So HPP is a non-thermal technology which products are subjected to a high level of hydrostatic pressure up to 600 MPa, which is 6,000 bar or 6,000 times the atmospheric pressure. Without heat and without chemical preservative, this high pressure can inactivate pathogen. So the technology allows to increase food safety, to increase shelf life. So it allowed our customer to protect their brand of any recall, pathogen contamination. Also, it given access to new market because the products have a longer life and they can be export. And the best things is that the quality is fresh-like, and the technology does not allows to remove or to reduce chemical preservative or salt. What is the limit of the technology? Concerning product, you will see in the next pictures. We have a lot of product now in the market, so there are a lot of possibilities with high pressure processing. Nevertheless, the limit is the water activity. If the product is too dry, it means below a water activity of 0.8, 85, 87, depending a little bit of the pH. When there is no moisture, no water inside the products, the efficiency of the technology, the inactivation of the microorganisms is very reduced, or could be almost nothing. So the technology works very well when the water activity is over 0.96, and could work between 0.87 and 0.96. This is, I would say, this is the main limit of the technology. So some example of the shelf life increase for different type of product, juice, ready-to-eat meals, cooked meats, vegetable dips. So I would say between 2 times and up to 30 times, depending the pH, the water activity, and the initial contamination of the product. Which type of packaging? In regular machine, in-pack machine, the machine which are not bulk. In the regular machine, the product is processed in pack, so the packaging need to be flexible and need to resist to water. So bottles, plastic pouch, tubs, trays, and vacuum pack can be used. From what we know, from our estimate, we think that in last year, about 2 million tons of products were processed, of food products were processed under pressure. Which products? Well, this is a pie, or this is the percentage of the machine in the different industry. So the leading industry having roughly 24% of the HPP machine is the juice or beverage industry. So you can see some example here, mainly fruit, vegetable juices, but also smoothies, teas, coffee, quite a lot of products in, I would say, roughly all over the world, from India to Europe. The second main type of products processed under pressure are fruit and vegetable products, and I would say that the main application or the most successful product is the guacamole. But you can see here we have example of hummus, fruit purees, dressings, soups, cold soups, but of course many guacamole products. The third type of product, very important products processed under pressure are meat products, and today Jaume Planella will give some more examples. But I can show you different type of products: cooked, cured products, and also raw products. So a few hamburgers and products like that. Before explaining the other application with a little bit less of users, as you can see here, I have to precise that about 17% of the machine are for tolling, which is a company that purchased the machine and installed the machine to process product for the others, so giving the HPP service, or co-manufacturing. It means that they make the juice or they make the meat, and then the HPP and they sell to other brands the product. So this is what you see on the pie, the 17%. So coming back to an important application is the processing of seafood, and it's mainly shucking and meat extraction. And I would say that the products that is or the animal that we process more under pressure is the lobster, as you can see. But we have also some example of fish products, oysters, well, quite a lot. Also, smaller application are the ready-to-eat products, ready-to-eat meals, pet food, and dairy products. Here you can see some example of ready-to-eat meals and pet foods. This is a growing application, and some dairy products. So I thank you for your attention, and I will be available for some few questions at the end of the webinar after the third presenter. So now I'm pleased to introduce for the second presentation David Rodríguez Lázaro. So David is a doctor in veterinary medicine, specialized in food science, public health, and molecular microbiology. He's associate professor and head of the microbiology laboratory at the University of Burgos in Spain, and he has carried out several research, and is collaborating with several European research team. His research work focus on the detection and the study of major foodborne pathogen, and he also studies new and emerging food preservation processes and their effect on microorganisms. And he has about more than 100 international scientific articles and book chapter, and several of the articles, especially on virus, for example, in food purees, are with HPP. So this is, we invited him because he's really an expert. I just want to finish the introduction of David. He was awarded in 2013 with the Jaime Ferran Prize by the Spanish Society of Microbiology, and I will let him explain us the contribution of high pressure to the control of bacteria, viruses, and parasites. The floor is yours, David.
Okay, so I would like just will go fast. I mean, just I would like just to stress that the real importance of the food industry. So this is a real important market nowadays. We can see the huge increase of the demand of pork meat during the last 25 years. And also the perspective for the future is as big as now. So if we compare the increase of the population in the different parts of the world with the demand of the food, we can see that the increase of the demand of the different types of food will be much bigger than the increase of the population, regardless the area, both in development and in developing countries. And also, when you visit a market nowadays everywhere, you can find products from different parts of the world, just as an example of a globalization. And this what is very interesting for us as a society and as individuals. The point is that and also sometimes the food that we are introducing, we are also sharing the microbiota that these foods contain, and therefore some of them could be just pathogenic. And we can find even different blocks in which we can stress this, like this worries about the listeria problem, and also just from some colleagues from Denmark, just making just the joke about, okay, salmonella is everywhere, even with breakfast food. But sometimes the reality surpasses fiction, and just 1 year ago or 2 years ago, we have an outbreak of salmonella in breakfast desserts in the States. Therefore, we have problems all the time with potential pathogenic microorganisms associated with food, and food safety is an important issue. So there are different definitions about what is food safety, and for me the most interesting definition could be just that provided by Wikipedia, that because consider food safety as a scientific discipline. The interesting thing is that food safety is just the way in which we conserve our food safe and guarantee the health of the consumers. And the question is food safety really a big issue? Okay, the World Health Organization, WHO, some years ago established that the number of deaths associated to food every year in the world is around just 2 million of people dying, associated to more than 200 different diseases. And if we compare with the 3 priority diseases for WHO, AIDS, malaria, and tuberculosis, we can see that none of them separately achieve this huge number. And also WHO calculate that every year there are more than 1.7 billion of cases in the world, affecting more than 200 million of people in any point in time, and producing more or less 60 million of liters of diarrhea. That is this is the equivalent of all the water passing over Victoria Falls just in 1 minute. And in USA, the government, the USDA has calculated the estimation of the impact of foodborne diseases annually in the States, and they calculated that there is more than 9 million of cases associated to 31 known pathogens. And when we consider not only those known, but also with a known etiology, this number is almost 48 million of cases per year. And also, it represents a huge economic impact. The calculation of this number of cases is that every year in the States, it costs $77 billion. That it is more or less what European Union invests in the European Program for Research, the pluriannual program, 5 years program. And if we consider only what European Union invests in science in general, for the last 5 years, the economic impact of the foodborne gastroenteritis cases in the States represents 3 times what the European Union invests in science. And also, it has a huge social impact. So in some surveys done in Europe, asking just citizens about the different aspects affecting the health, we can see here that even when it's different in the different countries, we can see that in general, food safety, the safety of the foods, represents a huge important aspect affecting the health of the citizens. For example, we can see that in Netherlands, the perception is low, but in other countries like Italy, almost 1 out of 5 citizens consider that the safety of the food is a very important aspect affecting the health. So the point is that when we can see this scenario, the question that we should address is if we have the correct tools to handle this serious problem. And okay, the idea is to use a science-based approach called risk analysis. And this risk analysis has 3 different aspects: risk assessment, risk control, and risk communication. In the first one, we need to define not just the prevalence of the different pathogens in different food commodities, but also the potential exposure of the consumers to these food items. And just related with my talk, the second aspect that is very important is how to control this potential risk associated to food. And we can do just using a combination of barriers in order to affect slowly the food quality, or just using individual barriers that are the normal approach that follow in industry. And just finally, the third part of the risk analysis is the risk communication. That is, and it is a task for the government. So we have different alternatives for food control. I mean that in general, it's well established that the thermal treatments are the standards for inactivation of different foodborne pathogens. However, the thermal inactivation has a strong effect on the quality of the foods, both not only in the food characteristics, but also in the organoleptic or sensory characteristics, and also sometimes in the nutritional value of the foods. Therefore, the food industry has been working in the last 30 years in order to develop different alternatives to change this approach of to establish order that can have less effect in these parameters. One of them is using non-thermal physical approaches like HHP. In general, all these non-thermal technologies should produce food of high nutritional value, or what it means that the nutritional value is affected or affected slightly. And also, these treatments should maintain the organoleptic properties, the flavor, the texture that the consumer expect to find, and also 2 important aspects. We need to obtain safe products, and also sometimes the idea is just to extend the commercial sale life of the products. What it at the end means that have available products more time in the shelves of the markets, or just in the shelf of our refrigerators. So HHP is one of these non-thermal treatments that is used for both approaches, for the self-life extraction and also for inactivation of pathogenic microorganisms. However, when we face the implementation of these technologies or the implementation of HHP for a particular purpose, we need to get a consensus between just the maintenance of the sensory food characteristics, including the nutritional value, in order to maintain added values in the market, with just the objective that can be cell-life extraction, or most of the times is just inactivation of different pathogens. This is very clear, for example, in the dairy industry with thermal treatments. Everybody knows or assume that the treatment, the heating treatment, should be as big as to guarantee the inactivation of viable microorganisms such as Brucella or Mycobacterium tuberculosis, and it also must be as low as possible to avoid just the production of the fat line that is not a good or positive food characteristic. So a similar approach should be followed when we want to establish a new protocol of inactivation by HPP in our products. So we need to guarantee that the products pressurized, treated with HHP, maintain just the format, the texture, the color, or are as much similar as possible to these products that are not treated. And also we need to maintain different aspects such as pH or grade bricks or viscosity or other aspects. And also we need to maintain also important components or nutrients that are associated to the product, or nutrients that provides an added value to the products. For example, could be just antioxidant components like flavonoids or phenolic components. So when we want to plan to face an approach of an activation, we need to be completely sure that these components are not loose in the treatment. And we can see here that the different treatments that use in berries or in sweeties doesn't have a huge effect on this kind of components. And also, we need to guarantee that the expectation of the consumers are satisfied, and and I mean the sensory characteristics, the taste, the flavor, the odor, the color, and we need to be completely sure that the treated products are as similar as possible to untreated. And for example, in this study, in different fruits, we can see that usually the untreated, the HPP produce or generates products with similar characteristics in odor, taste, and flavor or color to the products untreated. When we compare these products with products treated with a middle heating approach. So once we are completely sure that this first approach is achieved, we can now just to focus in this industrial approach, what we want to do. One of the things that we want to do is just to extend the shelf life of the product in order to increase the logistic procedures of the company, so extending sometimes even more than 3 times the expected shelf life of the products. So here we can see, for example, the quality or, sorry, the parameters in aerobic mesophilic bacteria, in psychrophilic bacteria, and yeast and modes are more or less the same when we compare them with a middle heating approach, and the results are much okay. And after 4 weeks of treatment, we can see that the values of these different quality parameters or microbial parameters maintains much lower than the initial ones before the treatment. Other approach that can be used is the application of HPP, sorry, or HP, sorry, just for inactivation of different types of foodborne pathogens. This is nowadays almost a standard procedure. For example, in the States, for different products, it's clear that if you want to guarantee a food safety objective of 4, it means at the end of the day, an activation of 4 logs, you know exactly that you can inactivate Listeria at that level using a treatment of 600 megapascals during 6 minutes. In general, in the different type of microorganisms, the treatment is variable. And we can see here that this variability is similar or a little bit smaller than that observed in the heating treatments. We can see, for example, that for Listeria monophytogenes, the variability in Listeria monophytogenes is much smaller than the variability when we apply heating. And also, there is different effects in the different bacteria. So in general, in products with a neutral pH, high activity of water, the most resistant or bacterium is Staphylococcus aureus. And even when the pH become acidic, or even in a neutral pH, when the activity of water is lower. And also, an interesting approach is or aspect is the resistance of the bacterial foodborne pathogens in comparison with other treatments. And we can see here that the product parameters affects largely the efficacy of the treatment. But when we compare the resistance or the differences obtained by HHP with heating, we can see that these aspects are quite similar. So we can see that the pH or the activity of water have a large effect both in heating and in HHP. And also we can see that the subletal injury or the recovery conditions can have also an effect. And if we want to see this graphically, we can see that subletal stresses, pH, water activity, the environment or the medium composition, and even the growth phase, and even the temperature can affect the efficacy of HHP. But as we can see, in all the circumstances, this efficacy or this variability is smaller than the variability observed when applying heating. So, as I told you, for bacteria, HHP has become a standard procedure, and I have put here just a table, just following the introduction picture. I put just typically Mediterranean meat products, and we can see that in general, we can achieve successful inactivation of Listeria monocytogenes. As later my colleague will explain, is one of the bigger headaches in the meat industry. And also, nowadays, we are start to using this technology, HHP, for inactivation of viruses. Again, the variability of the fed is big, depending not only the viruses that you are inactivating, but also in the environment in which the virus is present. We can see that the effects of in the same virus can change in the different products. And sometimes we can even not see any effect of inactivation. For example, with poliovirus, we can see that this virus is very viral-resistant. Therefore, as I told you, the HHP in viruses has a variable effect depending not only in the conditions that we apply, but also in the conditions where the food are. For example, a treatment of 600 megapascals is able to inactivate a virus model, and we can get just one log reduction, a D value, just in less than 1 second. And we can get 6 log units in activation just after almost 3 seconds. However, when we use a lower pressure, we can see no reduction, and in a middle treatment or mild treatment, we can see the effect of the different circumstances. For example, we can see that when we inactivate the virus at 350 megapascals, we can see the inactivation of the virus quickly in cell culture media, and the effect of this inactivation is reduced when we make the medium more acidic. So in this particular case, the acidic pH produce a baroprotector effect. However, something similar we can see when we add to the medium sucrose or other components like carbonatum or calcium. Okay, so different components of the food therefore can have a baroprotector effect in the viruses. And when we move this approach just to foods, to real scenarios, we can see different situations as well. For example, when we test the effect of HHP in noroviruses, that is the bigger or the biggest cause of gastroenteritis worldwide, we can see a huge inactivation in both products usually associated. So the latest cases of norovirus outbreaks, for example, here in Spain, were related with bottled water, affecting more than 4,000 persons. And we can see that mild treatments of 400 megapascals can guarantee 5 log reduction and activation of 99.999 inactivation. And also in other products that can be relevant in the norovirus transmission to consumer, that are berries, we can see also a very efficient inactivation using just HHP both at 400 and 600 megapascals. In other study recently published, we can see also similar results, not only in the puree of these berries, in strawberry, blueberry, or raspberry, but also in the foods themselves. And in the same time, we got efficient inactivation on the viruses, not affecting to the food characteristics. We can see that the change of the viscosity, the change in the color, or the change in the aroma, on the color, on the overall acceptability is more or less the same in the control and in HHP. When we evaluate the inactivation of HPP in norovirus in other food products, for example, in shellfish or in squid, we can see similar results. And also, we can see efficient inactivation in other foodborne or enteric viruses like hepatitis E. And as I told you before, depending on the strain that we use, we can see a very big variability. In some strains of hepatitis A, we can see just only a 1 log inactivation, while in others we can see an inactivation higher than 4 logs. And also, in this case, we can see a potential effect of the pH during the treatment. And here, whereas in the adenovirus, we can see a baroprotector effect, here in the hepatitis A, we can see a synergistic effect of the acidic environment and HHP. And also, we can see similar effects in foods, in the inactivation of hepatitis A in food, efficient inactivation, and also in there is just a paper published last month in activation of hepatitis E virus, that is a new emergent foodborne virus. And here, what we can see is that inactivation. This is the first study published, and I think that we need more studies on that. And we can see that in cell culture, inactivation only achieved 2 logs. And when we check what happened in a real product, the inactivation is quite poor. We don't observe a 1 log reduction, and what we see in pork patty after 600 megapascal treatment, we can see just a 50% reduction. And finally, there are some studies, not too many, on parasites, both in food and vegetables. And when we can see the effect in Cryptosporidium, Cyclospora, and Toxoplasma is very efficient, we can see a reduction or more than 4 logs reduction in the case of Cyclospora and 3 logs in the case of Cryptosporidium, and also in meat products. Here, while the treatment in anisakis and in Cryptosporidium was quite okay, we can see a reduction. We can see, however, that the inactivation in Trichinella is not efficient when we do the meat contaminated with Trichinella othis to the mouse. We can see by bioassay that the animals get infected, and therefore we can conclude that the treatment was not successful. However, the other new emergent pathogen, that is Toxoplasma gondii, usually associated to meat, we can see that this treatment looks quite promising and inactivate tissue fish. And again, I would like to thank to Hyperbaric for the opportunity that provides me to present some ideas about HSP, and I would like to thank to all of you just for the attention of this talk. So thank you very much.
And I'm very pleased to introduce Jaume Planella. Jaume is a food engineer from the Polytechnic University of Catalonia, and he has a master in product science from the University of Bristol in UK. And he has been the corporate director of R&D at Noel Alimentaria for the last 16 years. He will explain a little bit more about this company, but Noel is one of the leading manufacturer here in Spain of meat products, fresh meat, cured and cooked products, sausage, ready-to-eat meal for domestic markets, Spanish market, and also for international markets. Jaume's vision has been fundamental in the launching of innovative products and, of course, of the HPP ones. And those products, many of those are really successful now in the market, especially sliced meats and also veggie meats now. Just to precise that Noel, the company Noel received an innovation award, Innoval Award in 2016 for the award for trends in health and confidence. Thank you very much for giving your testimony and for explaining your experience with HPP.
Right. Thank you very much. First of all, to the team of Hyperbaric for having us here, having the opportunity to explain to you our case and our company. First of all, let me go to background the company with just a few tips. Few tips about the company. So the company is a family-owned company, 100% family-owned. It was founded in 1940. Today is one of the 5 top Spanish meat companies. We are 1,600 employees, and last year our turnover was exactly 304 million euros. At the moment, we have 14 manufacturing sites, and we export to more than 60 countries. Noel is the first charcuterie exporter of the Spanish charcuterie, and also we are the first producers of the jamón serranos under the Consortium Code of Practice. This slide shows to you, apart from the turnover of the last 2 decades, which has been a consistent growth, is more to show to you the variety of the product we've been producing for the last nearly 10 years. That variety of products, some of them they're very innovative. That is a clear indication of how dynamic is the company, and HPP processing is something more about part of that dynamism of the company. So you could see on the top of the slide some, for instance, a Spanish Serrano, traditional Spanish Serrano product, sliced, with a difference, with this no preservatives. So that is all natural. We are the biggest producer of all natural Serrano ham in Spain. The rest of the product is it could be something quite particular, like juice, which is cold press and HPP in the middle of the picture. Sushi, for instance, meat snacking. If you see one back there, which is a biltong, is a recipe from South Africa, similar to jerky in the US, which we think is better than jerky anyway. But is a joke really. Those products are really good. But that one is very peculiar, and is no additives, and is dry until we get a very low water activity. The next one, as I said at the first slide, we supply 60 different countries. This is just a picture of how we are in the world represented. And obviously, we leaders in the majority of the biggest markets, the markets which are the most dynamics. Places like UK, we're leaders in the UK, we're leaders in the US as well, we're leaders in Australia, for instance, we're leaders in South Africa, and we supply the majority of them. The aspect of the commercial for the company has been actually having the best partners in each country. So we supply the #1 retailers in each country. We supply, for instance, Costco in US, or we could supply Tesco worldwide, Carrefour worldwide, etc. The next one, it shows something very common to explain when we discuss innovation. For us, innovation is actually based in four very clear pillars. The first one is indulgent. So we have to produce good products. The products have to be good. If they're not good, there's no point to go on. Next one is convenience. We need to design products for a certain period of time we want to consume them very clearly. Next one is health. We've been talking about health for the last 10 years, but now nutrition, it might be, and I'm sure it is more important than health. So nutrition is a leading aspect of the innovation. And lastly, sustainability. So planet crisis, sustainable planet. So we all aware of this. So it's part of one of the variables for the innovation. And all the pillars, they have to be involved by the food safety. So food safety is something never questioned. So food safety is there for sure. What is our experience with the HPP technology? So we 10 years ago, we started when we built a company called APA Processing, and that company was designed as a contract company. It was designed as a toll company. So it was designed to process our product and products from other companies for all different sectors. We designed a site specifically for this purpose. So there's a linear processing design where we have an intake area, a processing area, and a dispatch area, and everything is clear. It's absolutely very difficult to get across products into it. Everything is linear. The technology we use is the Hyperbaric 420 liters. This is the picture you see on the corner right. And the typical purposes of the technology and the parameters we use are: we use technology for preserving the products for life extension mainly. We use levels of pressure from 3,000 to 6,000 bars. We apply to end products and we apply to intermediate products. That means we could actually apply to end products when the product is already finished and packed, ready to go to the customer, but we could actually process product we want to use as an ingredient for another final product. I might explain. I could use, for instance, chorizo dices of chorizo as an ingredient of a platter, and I'm going to assemble that product in a high care area. So I need the ingredient to be as safe as possible with the lowest level of micro counts. So that's the reason I'm saying intermediate product in here. We use also vacuum or MIP packaging. People think that well, vacuum is the perfect. Of course, it is the perfect packaging for HPP. But MIP is possible. It's possible for juices in a bottle, as Carole explained before. But we use both, and we have examples of both. I'm going to share to you later. And some of the aims of the technology is actually selling the product the product into a refrigerated cabinet, but also selling the product, not stocking the product, but selling the product in a non-refrigerated area. And finally, the technology has been very useful for diversifying our portfolio and giving to the products added value, or even added value for going to a specific country with a specific requirements. In this one, it's just we want to show you something that Carole explained before, and this reflects the reality in our production site. So in this graph, you see the number of cycles we've been producing from 2013 to 2019. So the darkest color is the meat product, the meat cycles. So the cycles dedicated to meat, and the paler ones are the ones dedicated at non-meat products. So the evolution from the last 10 years is what Carole explained, is been growing steadily, and it might be growing steady for the meat products, and probably some novel foods have actually been growing even faster. Right, sorry. So the next 4 slides, I just prepared for you 4 examples of products, 3 of charcuterie and 1 of juice, to explain to you some details about this product. The first one is the Serrano ham, Spanish Serrano ham. When we talk about charcuterie, and when we talk about meat in general, what actually it is a nightmare for us is that the count of pathogen bacteria, pathogens like Listeria monophytogenes or Salmonella, but it could be a Staphylococcus aureus as well, or it could be E. coli as well. So mainly, I'll show to you here the results of treatment, HPP treatment, with the product I actually you could see on the left side, depending on the water activity and depending on the pH. In this case, on the left, you see the picture of the product. It is a ham. It doesn't look like a ham, but it is a ham, a deboned ham. So we just taken off the bone and we press it in a lock. So that operation, in a way, is an open window for all the bacteria to go in there. So although we do it very well, there is a risk of a recontamination during processing. The one at the bottom is even heavier, because that one, it is a small ham. We form from a block, from a lock like the one at the top. So in that case, even the handling is heavier. So the graphs on the right show to you the behavior of the treatment when you have a different water activities. Water activities is a key parameter, and also, of course, as Professor Rodríguez said, as the higher water activity, better result. In this case, with a water activity higher than 0.92, you have a reduction in Listeria of 4.6. But if you have a water activity of lower, in this case of 86, you have a reduction of 1 log, using 6,000 atmospheres and 8 minutes. In this case, it's the same one, but doing that in the product already sliced, and using a less time of processing. On the right-hand side, you see the same graph for the Listeria, and you see the difference between Listeria and Salmonella. So Salmonella is more affected than Listeria for HPP processing. Next one is chorizo. It's another very, very standard and very well-known product of the Spanish charcuterie. Chorizo as itself is a very stable matrix. The pH here is about 4.7, and the water activity is lower than 0.92. So that matrix, that stable itself, is not the risk of growth of Listeria or Salmonella is very low compared to the ham, where I forgot to mention that the pH of the ham is 5.7, right? Which is a neutral pH, and very visible to growth Salmonella Listeria. In here, what happens is when we want to export the product and we want to make exactly of 100% sure there's no risk of presence of Listeria or Salmonella, we normally use the HPP technology. And the other thing, with if you look at the pictures on the top, in that case, if we want to modify one of those parameters and to have a higher water activity, then we could actually use HPP for lowering the counts of microorganisms. And the picture on the bottom is an example of ingredients. So we could actually use the HPP technology to drop or to ensure there's no growth of micro before assembling or before packing in a clean room. The third group of products are the cooked products. That one is a very traditional Spanish product, cooked product, bone-in. And what happens is in the deli counter, in the butchers, you could have a professional cutting the product and serving to you and giving the product to you. And the shelf life of this is probably 2 or 3 days or 5 maximum. In our case, we do it industrially, but we do it manually. So the handling of the product cutting is very intensive. So the product we have, the one at the top with the pack, you have the product already sliced in a clean room, but the handling is very heavy. So what happened here is the shelf life is very short. So we use the HPP for extending the shelf life from 10 to 15 days up to 30, 35 days. So that's 3 to 4 folds of shelf life extension, as Carole mentioned. But it's another important thing here, which is what I want to show to you with this graph, is the stability, the consistency of the sensory parameters. In the cook, you have after the treatment, you have a very consistent parameter of taste mainly. So one of the spoilage indication of the product, a cooked product, is the acidity. So in the HPP, you reduce that level of acidity of the product from the beginning to the end, especially the end. And the last group is some group absolutely different to the core business of our company, which is a meat company. So that is a nice example of to make a nicer story of the HPP. So with the HPP, as explained to you, we built a company and we had experience with meat products and other products from other sectors. And one of the products we actually discovered from the beginning that the demand of users was very high. So due to that, we created a new company called Hyperbaric, and that company actually gives the service of cold press squeezing system for the juices and the HPP at the same time. So here you have examples. This is one of our products. The juices is our brand. Coco Wilson is our brand for the coconut water. Other brands, clearly, some of them are commercialized in the UK. And at the bottom, there's some very popular sources in Spain, like or soups like gazpacho, like tomato sauce for bread, and different sauces in here. Next one is another application of the product, which is actually refers what I explained to you from the beginning, that if we get a very clean product, some of the companies that produce burritos in this case, or sandwiches or salads, they require a very low level of micro, and that would be a solution for those products. Finally, these are the parameters we look at. We look at when we design a product and when we think it would be possible to HPP process. But I would say when someone asks to me, is that product feasible for HPP? Apart from giving an answer related to those parameters I'm going to explain now, the next answer is let's do it. Let's try it and see the results, because there's a lot of parameters, very difficult to control everything, very difficult uh, to get the perfect product from the beginning. So in here, just to bear in mind that water activity is very important, pH is very important as synergy or complementary effect to the HPP. Packaging, Carole mentioned a lot about packaging. Packaging is very important. You see, if you deal with an MIP product, you have to be aware of the design, the geometry of the product, the edges. You have to remove the majority of the edges, trying to get brown shapes everywhere. It's important the gap between the product and the lid, how big it is this, how flexible is the packaging, is the different parts of the packaging they're going to touch the product or not, etc. And at the end, sensory. Professor Rodríguez has been talking about, he's been explaining a lot about sensory analysis. Sensory analysis for us is very important in the term that HPP modifies the sensory of all the products. That modification, it could be a disaster, like the lettuce or the salmon or fresh meat sometimes, and sometimes it could be imperceptible. So there's slightly changes which are not really, let's say, so important. Or some of them are even beneficial, so they're really very good, even better. The product after HPP is better than the one with non-HPP. And everything, when you take into account all these parameters, then you have to adjust the equipment. So the adjustment is very simple. You have actually two things, and the third one is the temperature. So you have the pressure, you have the time, and temperature is something you have to keep just control. Sorry. And finally, for us, HPP has been key for the expansion of the business worldwide. So it's been very important for the US, for instance. The US is very restricted in terms of the level of micro of the products coming from abroad. So Listeria 0. So we have to ensure there's no counter Listeria of any of our products. It's been key for other countries like Australia, for instance, with the same regulation. Japan, for instance, similar regulation a few years ago, etc. It has been important as well with some countries with difficulty or just with a supply chain not well developed, where products like ours, HPP, we have an extra huddle of safety. And of course, it's been a very important point for differentiation in terms of reducing preservatives on some of our recipes and some of our products. So that's all. So thank you very much for your attention, and thank you very much again to Hyperbaric.
We have a question about the labeling of the HPP products. Is there any requirement? Do you inform on the products that you process under pressure? So I don't know if you want both to reply, or perhaps Jaume, as you have a lot of products.
Yeah. Yeah, there's no requirement to in the meat products. There's no requirement to say exactly it is a HPP process. But I always explain the labels of the juice is very clear when you explain the whole process, and you explain how you squeeze the fruit and how you get the juice and how HPP process with a nice bottle with several arrows around the bottle. And I think that is a very nice way of explaining the technology. Just trying to get people aware, not aware of the technology, which is a very simple technology, and I mean, it's a very nice technology as well.
But it's not mandatory, but it's nice to explain to the customer. I don't know.
No, sorry.
I'm sorry.
I can't hear you. No, it's not mandatory for the. I haven't found in all these years any for the meat products. I'm talking for the meat products. There's no customer actually asking us to declare the use of HPP.
From my experience, there is no country asking to declare HPP on the label, so it's up to the food provider. I think the veterinary, David, you can confirm that there is no requirements from the veterinary food inspections at least in Spain. I'm not sure, David, you can hear us.
Yes.
No, very difficult. I can't hear.
Okay.
Difficult for me.
Yeah,
okay.
Me too.
Okay, so sorry for that. I will try to be clear asking the question. So for David, we have a question about the difference between vegetative microorganisms and spores, bacterial spores.
Okay, yeah. I mean, well, there is a huge differences. So HPP sometimes has been called non-thermal pressurization, and particularly the effect on bacteria is similar that effect you can see heating or pasteurization. So it's quite effective for vegetative bacterial cells. So you can even get 4 logs reductions, or even more in the case of Listeria or some Enterobacteria, but it doesn't work for endospores. You need to organize a procedure that combines other options or different treatments in order to get an activation of spores.
To add like nitrates in the meat products or to avoid germination of spores. Yes, this is a mine technology.
Yeah.
We had a question, Jaume, regarding salt reduction. Sorry, or reduction of heat process of the products thanks to HPP. You could comment on that?
Yeah. In terms of the salt reduction, I think I have no experience of actually combining the two, salt reduction and HPP, or actually reduction the salt because I'm using HPP. To complete the answer, I would say that just bear in mind that one of the things that happen when you use HPP with meat products or cured products, you get a feeling or sense of saltiness higher than before. So that is the sense of saltiness, no increase of sodium or not. It's actually the same level. But salt or sodium, we use salt or sodium for other purposes. So not just for the we need the sodium for the technology of the process itself. For the cook ham, for instance, is very important. For the cube product, is very important. So I mean, if there is any option of this, I think it's very limited, right? I'm not saying no, but I mean it's limited in terms of the advantage you're going to get for an extra process. And in terms of the thermal process, if you could avoid thermal process, I think it's absolutely the same. So using the thermal process or cooking, so you need the cooking to get the product itself, the structure, what you're used to. rather than I want to uncook the product and then HPP. I think this is not the right way. And in a cooked product, HPP is actually important when you have a cross contamination after a heavy handling. So after a slicing or different types of slicing or assembling. So you get an extra cross contamination here. Then HPP after packing, I think, is a good option.
Okay, thank you very much. We are receiving more and more questions, but I think I will have one repeated question for David is about inactivation of enzymes. If you can give us a short short reply on the possibility of HPP for enzyme inactivation. We don't hear you because your microphone off.
I don't know if I understand correctly. The question is regarding the inactivation or the threat of the HPP for enzymes. I can tell you that okay, this was not the purpose of my talk because we were focusing on safety, but what is evident that one of the alternatives of the use of HHP is just the inactivation of particular enzymes, for example, in the case of guacamole or others. In this case, HHP is an option and can inactivate enzymes. At the end of the day, enzymes are proteins, and the HHP affects less strongly than maybe or particularly heating, but it's still affecting. Therefore, for some purposes, this inactivation could be positive, like for example in the case of guacamole, but in general, they are effective.
Okay, thank you very much. And so there are two questions for me, I guess. Perhaps David or Jaume can comment, but we have a question about the possibility of processing frozen products. And on the machine side, I would say that it's very difficult because the pressure is transmitted by water. If we place a lot of frozen product inside the vessel, the machine, then the water surrounding the product can freeze, and then you would have big problems of reliability, problems with the valve, especially at the depressurization. So we do not recommend to process frozen products. And on microbiological side, frozen products could reduce the efficiency of the inactivation of microorganisms because it reduces the water activity. From what I know, but perhaps David can comment, this is not really a clear effect. That's what we've seen with some customer. If the product has a low water activity and is frozen, the inactivation of Listeria, for example, can be reduced. So we do not recommend. Okay. And the other one, the last question, I think, for me is that if it's possible to process products in glass or to pack products in glass, I would say that in the impact machine, the regular HPP machine, this is not possible because the glass is not flexible to withstand the compressibility of the product and of the headspace, which is roughly 15–20%. But in the bulk machine, yes, as the liquid is processed in a big pouch and then sent to an aseptic or extended shelf life tank. After this tank, yes, of course, the product, the liquid, the juice can be packed in glass bottle, for example, or any type of packaging, of course, plastic, carton, or the packaging that the customer likes. So I think we have now to go to the end of this webinar. I would like to thank you very much very much Jaume and David for their nice presentation. And I have to precise that we will send to all the participants a link, and thanks to this link, they could have the record of the webinar and the question also. So this will be done in the next 2 weeks, I hope. And so finishing, I would like to introduce the next webinar. So this webinar will be focused on seafood, and the speaker will be my colleague Vinicio Sermons Moreno, and we will have also the participating Robert Birch. Robert works in a technical center, and he has developed a nice new process for deshelling crab meat. So this webinar will take place on May 2026, and we hope that you will be with us in this webinar in May. And just to finish, thank you very much for being with us. I hope you have enjoyed the presentation, and I would like to thank you for your attention. Thank you. Thank you very much. Goodbye.
Thank you.